Did you know the same physics that makes an apple fall is what keeps the planet spinning around the sun? Mind blowing, right? But most people think physics is too hard, or only for geniuses. Spoiler alert, it's not. Let me show you why. Physics is the study of how everything works, from the tiniest atom to the largest galaxies. But here's the thing, it's not about memorizing equations. It's about understanding the world around you. And in this series, Physics for Everyone, I'll make it fun, simple, and actually useful. Physics is the study of matter and energy. Simply put, I think of it as the study of the entire universe, right? It's really cool, okay? Um but it can be broken down into a couple different branches or subfields of physics. There's mechanics, there's thermodynamics, electromagnetism, optics, acoustics, quantum mechanics, and relativity. Um, Mechanics is more so the study of forces, of motion, so things like speed, acceleration, velocity, momentum. These are going to be things you'd come across in mechanics. In thermodynamics, we have the study of energy, work, heat, temperature, and the way these things interact in a system. In electromagnetism, we have the study of electric fields and electric charges, along with magnetic fields and magnetic charges. We also have radiation. So, electromagnetic radiation, you've probably heard of this. Light is a form of electromagnetic radiation. Speaking of light, there is a branch known as optics. In optics, it's the study of light, right? How refraction works, how reflection, just the properties of light. And there are a lot of applications that we can harness from light, right? So we have fiber optic cables, we have glasses, telescopes, microscopes. We can even do optical computing, which is pretty unheard of, or it's not as it's not as known, but it's pretty interesting. Um, Acoustics, of course, the study of sound and the properties of sound. In physics, you'll come across a lot of waves. That's a big topic in physics. Energy, fields, and waves. Those are really big, and vibrations, big topics in physics. Pretty much everywhere you look, on the most fundamental level, it is we're just that energy, vibration, and fields. Um, but that's what physics is about, right? You get down into the smallest things and the largest things, and the smallest things like quantum physics or particle physics or nuclear physics or atomic physics, but more fundamentally quantum physics. And these things can reveal a lot about reality, and it's it's really interesting stuff. It's I don't understand it, uh, but I kind of just put them together, even though they're technically different fields. Quantum, atomic, nuclear, and particle physics, they're different. Technically, they're different because like atomic, more atom, is more like atoms. Quantum physics, more elementary particles, quarks, stuff like that. And nuclear, I think of more like applications of like like atomic physics, like energy generation, nuclear fusion and fission and all that jazz. And a notable mention, astrophysics. I know that is kind of more tied to astronomy, but it's a notable mention, um, especially because it deals with things on like a larger scale. And when I think of things on a large scale, I think of relativity and gravity, which is very important. Physics is fundamentally about answering three big questions. One, why do things move the way they do, and what caused this motion? Two, How does energy work, and what is energy? And 3. What are the contents of the universe? What is the universe made out of? With some background information, you can kind of see how these different branches of physics accomplish answering these questions. And something I should note, or I should have noted, is that it can be broken down more strictly into two um, more main branches of physics, I guess. So classical and modern. Classical physics would be more. Um, now there just, but before I say this, there is a classical and modern interpretation and approach to these different fields. Um, I guess besides relativity and quantum mechanics, those are probably more strictly modern fields. But mechanics, thermodynamics, electromagnetism, optics, acoustics, these have classical interpretations, and then of course quantum mechanics comes along and relativity, and then you have these different interpretations of mechanics. Okay, so I'm going to demonstrate a thermodynamic principle, and I guess, well, a physics principle. There are a lot of different branches that go into hand with this, but take your hands and rub them together like this. You'll notice that there is some resistance when you push your hands hard together. This resistance, when your hands rub up against each other, it's creating friction. And because of this, there's also heat. You can also think about it like this. There's chemical energy in your body, and you're converting this chemical energy into mechanical energy in the form of kinetic energy because of the motion, and as a byproduct, because of friction, there's heat. And then you can see that this heat can be transferred to other things. I can feel it. Boom. Physics isn't just for scientists. It's what powers the internet. It's what makes using a smartphone possible. It explains why rainbows form after it rains. And it also explains the aurora lights. It also explains robotics. And when you go to the doctor to get an MRI, that has physics involved. Once you start noticing, you'll realize physics is literally everywhere. This is just the beginning of Physics for Everyone. In the next episode, we'll explore how gravity actually works, and why astronauts feel weightless in space. So hit subscribe, leave a comment down below, and tell me what physics topics you want to explore. Thank you.